Hi everyone. We're here back here today with Brandon, Amber, and Chris, all from the Starburst Institute that Paul Lavalette started, and we're on the fourth of 8 sessions that we're going to talk about the papers that I wrote about Paul. Back in the spring of 2021, I sent Paul a message when I sent him these papers. And I said, "You, sir, are the second smartest man to set foot on terra firma," of course, Tesla being the first. And at that point, I nicknamed him Tesla 2.0. And it kind of stuck a little bit. So it's really cool. So Brandon's going to start reading. And you guys can jump in also with comments, because that's why we're kind of doing it here. Chris, if you've got anything you want to add or know about, or anything, just jump in, you guys. So let's go ahead and start this.
Okay, thank you, Eddie. Okay, so I'll just start now. It's page 16. The electrogravitic impulse effect could serve as an excellent drive for use in interstellar space travel. One could imagine a spacecraft outfitted with a larger aperture Bogdanov gravity beam projector that would be powered by a set of very high power Marx capacitor banks operating at potentials of up to 2 million volts and conveying its discharge to a superconducting electrode 70 times larger in diameter than the superconducting disk Bogdanov fabricated for his beam generator. That is 7 meters, 7 meters in diameter instead of 10 centimeters.
Yep.
The beam generator would be mounted at the rear of the ship and would direct its gravity pulses forward toward the ship's bow. It might be provided by an onboard free energy generator, such as the gravity wave power generator described in the next section, or by a solar effect generator, such as that described in chapter 10.
And chapter 10 would be in Secrets of Anti-Gravity Propulsion book for everyone.
Mm-hmm.
Most all of this information came out of that book. So I don't have Kinetics book. I've never had it, actually. Brendan's sending me the first one I've ever had.
And actually, chapter 6 has a good bit of information on the impulse effect and Podkanov's beam generator.
Yeah, I think we talked, if I'm not mistaken, we might have talked about this beam generator in the last one, because I just go 10 pages at a time and then we stop, right? So thanks, Chris. Yeah, more information. And is that in Secrets of Anti-Gravity Propulsion?
Yep. It's about starts on page 167, and then there's actually more throughout the chapter, like little bits, but from 167 to 72, I believe, has a good bit of info on it. In the, like I said, the Secrets of Anti-Gravity Propulsion by the great Dr. Lavalette himself.
I love it. Well said. Okay, Brendan.
Okay. It is possible to transmit shock waves at superluminal speeds, presumably because of their ability to surf the forward moving ether wind. It should also be possible to accelerate a ship to superluminal speeds. The gravity beam would not only propel ship forward, but it would also push forward the ether within its superluminal tunnel. Is superluminal space travel possible? The answer is a resounding yes.
And I'll just stop you there for a second, Brandon. I wanted to talk about that superluminal speed. I have a friend, Frank Chili, who actually knew William Tompkins the best of all of everyone. And in the Solar Warden program, the old version of Solar Warden, not the new ones that they're building now, it could go from here to the center of our galaxy in 45 minutes. So that is superluminal. I don't know exactly how fast. I remember in his books, Tompkins talks about 6. And I was like, what is he talking about? 6. And he keeps saying 6. And I'm like, what is that? And then you read on, and it's 6 times the speed of light, is what he was talking about. So just wanted to add that. But you can carry on, Brandon.
The first indication that microwaves
Could be used.
could be used for propulsion came about when it was discovered that microwave beams could move objects if the objects happened to be made from the right kind of material. An experiment in which low power microwave beam from
a klystron
tube was aimed at pencils placed on a table, caused them to move around. They found that the best propulsion effect occurred in materials that had a particular magnetic property. The effects were very frequently sensitive. A material that exhibits a resonant response to the electric components of what's that?
This is my handwriting is horrible.
Electromagnetic wave over
most frequent
C's.
frequencies.
Over most frequencies, the material's permittivity will have a positive value as a result. The applied electric field will induce a polarization in the same direction as its own field vector, as is commonly observed in most materials. Near a resonant frequency, however, the induced polarization will become very large.
I think that the materials large.
So very large that materials. Sorry, what did I say? Very large.
Very large. And then it says the material's large response.
But then the material's large response being something due to accumulation of energy from microwave
beam
resonating over microbeam resonating cycles resonating over many cycles. The energy stored in the exceed that delivered by the incident driving field. It can be so large. It can be so large that even changing the phase or sign of the incident wave would have little effect on the polarization oscillation. As a result, when the frequency of the incident wave is increased slightly above this resonant frequency, the applied electric field will be out of phase with respect to the induced polarization oscillation. And as a result, the material will respond by exhibiting
a negative
a negative permittivity.
This is really important, this
The
part.
induced polarization now being out of phase with the applied electric field. The electrons oscillating in the material will now resist the applied electric field, and as a result, the electromagnetic wave hill
Will exert.
The electromagnetic wave will exert a repulsive force on the material.
Yep, very important
Such
part there.
materials include silver, gold, and aluminium, whose resonances usually occur at optical frequencies. The same repulsive force phenomena occurs in materials that resonate with the magnetic component of an incoming electromagnetic wave.
Yeah.
The magnetic permeability of the material, mu, which normally would be positive, becomes negative at frequencies slightly above the material's resonant frequency.
Ultra important, that sentence right there.
And M is the symbol, right, for it? Like M, the positive M. I mean the capital M, I'm sorry.
The mu is a mu. It's
mu. It's a mu.
Oh, mu, that's what it's called. I'm sorry.
Yeah.
Thank you, Brendan.
Yeah. So yeah, that's really, really important. And it'll talk a little bit more about it as we go along here, but it's about finding the resonant frequency and then going just slightly above it. Right.
The material's response then is to magnetically resist the magnetic field of the applied electromagnetic wave. Materials that naturally exhibit negative mu domains include ferromagnetic or anti-ferromagnetic materials that exhibit resonances at frequencies. Ferromagnetic or anti-ferromagnetic materials that exhibit resonances. Such resonances usually occur at frequencies in the gigahertz range.
1 gigahertz. Yeah, very important.
Frequencies.
Yeah.
In the terahertz to infrared range.
There's only a range, right?
A group.
Yeah.
For example, a group of Japanese scientists have reported negative permeability in a granular
composite
material consisting of 70%
permalloy.
Permalloy.
Yeah.
When the material is exposed to microwave frequencies higher than 5 gigahertz. The greatest repulsive effects occurring when the incident wave has a frequency close to a material's magnetic resonant frequency.
Yeah.
Metamaterials whose permittivity and permeability both are simultaneously negative over a specific frequency range, causing them to exhibit a negative index or refraction.
Yeah, very important.
Negative index or of refraction. Since negatively refracting materials are full of resonances, those resonances can be exploited to enhance the scattering cross-section and what's that word?
And I think hence
the propulsive force on the material. Artificial metamaterial, which was made by constructing an array of straight wires and wire loop split ring resonators.
Yeah, and that's a picture of it right there that I drew.
Split ring resonator become negative over a frequency range of 10 to the 3 to 11 to the 5, 11.5. Is it is
Yeah,
that 10.3?
yeah,
10.3 to 11.5 gigahertz.
yeah. So very high frequency and still in a range of frequencies, right?
Another team created a meta material in a very different manner by incorporating metallic magnetic nanoparticles into an appropriate insulating matrix. This sounds similar to Brown's idea of embedding massive semiconductor particles,
Yeah.
such as lead,
Oxide,
such a lead, what's that?
such as a lead oxide.
Such as a lead oxide in the canonical dielectric.
I think it's supposed to say conical. It's cone
oxide
shaped,
in
right?
the conical dielectric
Remember?
material, dielectric material of his electrokinetic apparatus. I'm not sure what that word is there, but I said just call it material.
Yeah.
They achieved the best results with a sawtooth shaped waveform consisting of
that's really important. I just want to say that the sawtooth is very important, and what they're going to say next is ultra important.
They achieved the best results with a sawtooth shaped waveform consisting of asymmetric triangular waves that have
either
a step voltage rise or a steep voltage decline.
So yeah, so if you're looking at it on the scope, it wants to be really like a very quick impulse, right?
The shock wave pulses produced by Bogdanov's gravity impulse beam generator have a sharp rise at their leading edge and are capable of generating strong repulsive forces. Tesla also observed longitudinal repulsive forces being produced by the energy wave shocks radiated from his magnifying transmitter.
Very cool.
Being a negative
of that, right? Sorry, go ahead.
Being a negative voltage rise, the gravitational force exerted by Bogdanov's beam is predicted by the electrogravitic coupling relation to be repulsive rather than attractive, as is observed. Brown observed that the electrogravitic force developed by the electric field, in fact, increases as the nonlinearity of the field voltage profile increases.
Yeah, that's very important.
We're nearly at the end now. What's this word? Demetrion. Demetrion claims to have generated gravitational forces by energizing capacitors with sawtooth waves having an amplitude of around 15 volts.
So a lot lower voltage setup, right, than what we're talking about.
Most likely.
Yeah, I think, yeah.
Most likely, the wave amplitude must exceed 10 of kilovolts, tens of kilovolts, before this sawtooth wave thrust effect becomes large enough to be significant. Brown and Bogdanov both used waves in the range of 50 to 2000 kilovolts to get their thrust results. Project Skyvolt used
Magnetron.
vacuum tubes to generate their microwave source beam.
Mm.
They worked with frequencies ranging from 7 gigahertz, which is 7,000 megacycles, to upward of 1,000 gigahertz. Microwave ovens use 2.45 gigahertz.
Wow.
Just as
Need a lot of microwaves.
just as the length of an organ
Pipe tunes.
pipe tunes. Sorry. Just as the length of an organ pipe tune to pipe tunes. The
Pipe
length
tune. Yeah.
the length of the pipe to a certain pitch. The diameter of these cavities can efficiently tune microwaves to a particular wavelength.
And then there's a picture here of a magnetron that I drew.
Mm.
And I'm a tube expert, by the way, guys. So that's kind of why this is my sort of realm and territory, I guess.
Ah.
So that says magnetic field, cavity magnetron, and hot cathode and anode.
Yeah, and the anode surrounds it, right? And see how there's a negative and positive all the way around.
Mm-hmm.
Yeah, so it's very specifically designed. And what they're going to talk about next, barium titanate, is so important. Anytime you hear barium titanate, you guys should pay particular attention because these are the high K materials. And Chris, if you hadn't seen the first ones, you can just go onto Brandon's site and YouTube and have a look at all of them. We talked about barium titanate in the first one and the high K materials.
Sorry, I missed you guys.
Oh no, but that's why we're doing this, right? So that everyone can go and look, right? So, but they're all on Brandon's channel, right? And they will be all on my channel once we get them all done as well. So sorry, Brandon, I'll let you go again.
Skyvolt Group may have used ceramic dielectrics such as barium titanate polarized with high voltage DC potential on the order of 10 kilovolts per centimeter. Skyvolt team did not power their tubes continuously, but pulsed them about 1,000 times per second using a mechanical pulsar. This last page.
Yep.
Thyrotron tubes, which were able to produce shock discharge pulses, having a much sharper rise time. Thyrotrons had a fixed spark gap enclosed in sealed glass tube filled with hydrogen and used a third igniter electrode to trigger the gap to discharge. These discharges would be much like Tesla's shock discharges, except that the magnetrons would convert these pulses into microwave frequency shocks. To maximize the gravity wave propulsion effect, they had to operate these tubes well beyond their voltage specifications, powering them up to 250 kilovolts.
Which is a lot.
For comparison, one unclassified research paper published in 1956 described the development of a 1.3 gigahertz magnetron that operated in the range of 50 to 75 kilovolts and delivered power outputs on the order of 10 megawatts during its 10 microsecond pulse period. Okay, so that's that.
Yeah, we just decided to do 10 pages at a time, essentially, just so it wasn't too long and people can absorb everything as we go along. Yeah.
Yeah, completely understandable due to the vastness of the topic.
Yeah. And again, that's sort of what, I guess that's why I wrote these papers, is because I am a vacuum tube expert. And where that comes from, Chris, I was talking a little bit about the Cuban Missile Crisis. My father was in the Cuban Missile Crisis. He was part of NORAD, and he was a radar guy. And radar electronics are considered the pinnacle of electronics, essentially. So I never actually learned anything from my father because we argued a lot. So I didn't learn from him. But who I did learn from, his name was Deacon Erdek. And Deacon was also in the Cuban Missile Crisis, but Deacon was on the other side. Deacon was a Russian NORAD version or radar guy. So he did the same job as my dad, but he was on the Russian side. And Deacon came from around the area where Tesla came from, and Deacon was brilliant, absolutely brilliant. And he mentored me in electronics. So I've never taken electronics ever in my life. I only learned from self-learning and from Deacon, but I learned the Russian way. I learned the true Russian electronics. So that's why I'm able to do this and why I was able to write these papers, essentially. Because all I did really is, I mean, some of this is my information, but most of it is Paul's. And all I did was just find all the best stuff and put it all into one place, is essentially what I did, right? Now we understand why, because we're putting it on YouTube, and this is fantastic. So I want to thank you guys all before we stop the recording here for being here today, and looking forward to next week. We're going to do the 5th version of this. And so like I said, now we're halfway through it, which is brilliant. And I hope that everyone down the road can learn from some of this, because this is electrogravitics, exactly what is very most important to engineers. If you're going to learn something like Amber, for example, you know, in the future, this is the stuff you need to learn if you want to go work for Chris Beskar, right?
Yeah.
Which is the dream. And I'm sure that will probably happen, because, you know, you've met him now and he's such a cool guy, right?
Yeah, he is really cool.
Yeah. Yeah. So, and we're looking forward to having, you know, more interviews with him. I'm going to also have him with Sam. Sam and I are going to have an interview with him that's Sam promised to be broadcast quality. So Sam could actually send this to Fox News or whoever, because Sam has connections all over the world because of 40 years of being an investigative journalist, right? So that's what's really important. And so yesterday I told Chris about what we had planned. We've got some big plans and whatnot, and he's all cool with it. So we're going to get an interview probably in November sometime with him, and lots of really cool stuff after that. So I guess we can stop the recording here, and thank you again, guys, for everything, and then we can chat some more.
Thank you, Eddie, Chris.
Thank you. Thanks for having me.
No, this is